Hi, how you doing? Can you all hear me okay? Great. All right, I'm going to talk to you about automated testing of your infrastructure code and why you should bother, and maybe using your monitoring checks as a sort of initial starting point. My name's Jesse Reynolds. I'm a professional services engineer at Puppet, based in Australia. I live in Adelaide, but I work everywhere but Adelaide, pretty much. So, yeah, don't talk to me about working in Adelaide. So, infacode, or infrastructure as code. This is code that builds or configures your infrastructure, deploys applications, things like that. Maybe written in Ansible or Chef or Puppet or Salt or any of a number of other things. So just a quick show of hands, who's here is using code to manage their infrastructure in their organization? Awesome. That's great. I was hoping that would be the case. And just another show of hands, who of those people have automated testing of their infrastructure code and are sort of treating it like software? Yeah, so a lot fewer people, but yeah. People who didn't put their hands up a second time, put your hand up if you feel bad about yourself. Don't feel bad about yourself. But yeah, hopefully this will just give you the opportunity to sort of explore ways that you might get started with writing testing for your infrastructure. And if you didn't think that it was worth doing it, perhaps you will afterwards. All right, so writing tests has been a best practice in software engineering for a while now. So that we can test regressions and all sorts of things. There's different types of testing. So we've got unit testing, which might be written in technologies like JUnit or RSpec or Pesta, things like that. The unit testing just tests the smallest amount of code possible. So it's still very valuable to do, but I'm not going to be talking about unit testing here today that much. And then there's integration testing and acceptance testing, and sort of if you ask different people what these different things mean, you'll get different answers. Sort of with infrastructure code, there's kind of a blurry line between integration and acceptance testing and what those words mean. So yeah, we're just going to be I'm going to be kind of conflating those two things together for this talk. Infrastructure code is software, so you should write tests for it too. So if you've written code to do a thing, you want to make sure that it does the thing and it doesn't hit any errors, and that it doesn't do anything that it shouldn't do. So we're all software developers now, so we need to learn from software engineering how best to, handle this code. Realize that, if like me, you've come more from a system administration background than a sort of pure software development background, you really need to sort of start learning from the world of software engineering. But that can be hard. So why bother? I mean, it is hard. There's a lot of things to learn. It takes extra time to write those tests. If you've got something that just works, then just, that's great. Ship it, put it in production. Why bother writing tests for our infrastructure code? What is the point? So I'm going to tell you a little story. There was a bank. They had a trading room, fortunately, they still have a trading room. This wasn't the end of the bank. So it's a high-stakes, high-pressure working environment. Computers are essential to making the trades. Delays are not tolerated. Traders get pretty upset when their computers don't work. They had Puppet managing the configuration of their machines used by the traders. Puppet's managing the network interfaces, among other things, on these machines. So that's probably not something that's fairly conventional or even really recommended necessarily, is to manage the network interfaces as such, particularly if you're going to be managing the IP addresses of those network interface cards, which is what they were doing. They had two separate Puppet classes written by two separate teams. They had a Linux class, which also happened to work on Solaris, and they had a Solaris class which kind of worked on Linux as well. And the idea was that they weren't supposed to both be applied on a machine at once. You have one or the other being applied on a machine. But both classes got applied on these machines. So there was the classification was changed for all these machines on the trading floor to apply both of these classes to manage the network interfaces. So somehow the IP addresses don't get determined correctly. All machines get given the same IP address, and it's not routable. These machines can no longer contact Puppet to get a fixed catalog. They can't do anything, in fact, other than report the fact that they're off the network to the traders. So Puppet can't fix them without manual intervention. In fact, nothing can fix those machines now. There's basically hundreds of machines that all need to have their network settings fixed by hand. And the traders go ballistic, as you can imagine. So what went wrong? They had two methods for doing the same thing. So two different classes that basically did the same thing, and I don't know exactly what happened, but I am guessing that perhaps somebody got confused and thought, well, network interfaces should be managed on all the machines, so let's make sure that class is added, and not realizing that there was another class there. They'd never been tested in combination, which is sort of the point of telling this whole story. Someone set them to both apply by classifying them. The classes ended up conflicting, and the trading room stopped. So what can be done to prevent this happening again? Code review, hopefully, would have found that type of problem, but maybe not. If it was just done in classification, then code review could have looked fine with this potentially. Code review does turn up heaps of errors and problems, and it's a great learning exercise as well. So I'm not saying don't do code review. Definitely do code review. Unit testing, perhaps. So perhaps there was a error in the logic in the class, in one of those classes, in determining what the IP address for the machine should be. Maybe it wasn't robust enough. So perhaps unit testing would have turned that up, but maybe not. Integration testing would have, if you go to the extent of building a machine that has the same classification that your actual production machines have. And so that's really the point of what I'm trying to get at. So testing to the rescue. Integration and acceptance testing on real machines is an important part of your testing strategy. It shouldn't be all of it. You should do unit testing, code reviews, but also just sort of things like syntax validation and things like that to save time when you're writing code. So there's lots of other types of testing, but yeah, integration and acceptance testing on real machines would help in this situation. So what do we need to do? In order to run your integration tests, you'll need to choose or perhaps write some tools to execute the tests. There's quite a lot of tools available, and they all have their sort of pros and cons. And it is a bit of a job to work out what's going to be the right tool for you and your team and your organization. And you might need to try a few before settling on one to get your head around it. There's no sort of, yeah, you should use this tool. It's the best for all possible scenarios. Unfortunately, that is not the case. So you'll need to do some research and try things out. So the first thing that you're going to want to do, or that your tools are going to want to do for you when you push a git commit like a change to your code and it starts the tests, is it's going to need to provision a machine or use an existing machine that's set up for the specific task of testing this, this class or this scenario. And that's might be a virtual machine, might be a container. You know, it could be on Docker or VirtualBox or OpenStack or AWS or Azure or Google Compute. Then you're going to want to apply the code to the machine. So applying your Salt, Puppet, Chef, Ansible, or whatever system on that machine with the so all of the code sort of together. So all of the classes that machine is going to have for its production use. So we were trying to simulate a production machine or a testing machine in this fake setup, in our test setup. Then you need to execute the tests. They can be in many forms, different languages, things like that. You can use existing testing frameworks. You can write a bash script. There's lots of different ways to execute the tests. And then, importantly, examine the exit status. If it's like all good testing systems, you should return 0 for success and non-zero for an error occurred. And yeah, that is probably the most important output for your tests, so that you can hook that into Jenkins or whatever other CI you're using to report back whether the tests are passing or failing. And then drill down to each individual test so you can see which ones are passing, which ones are failing. Your CI system can then report that back to your pull request for code merging, or if it's like a scheduled sort of execution that you happen to run. So the test harness and all of the sort of systems that form part of it. What are some of the tools? So this is by no means all of the tools, but I'm just going to sort of quickly go through a few of the tools which you can use as a starting point for doing some research and having a play around. Again, this depends on what your infrastructure looks like as to which tools are going to work for you. What provisioning system you have, if you have a provisioning system, or hypervisor, containers, things like that. Also what languages your teams are skilled in. So if you're if you're more about writing Ruby or Python or things like that. And the systems you're already using for configuration management. So if you're using Puppet or Chef or Ansible or Salt or CF Engine or any of these things, then that'll obviously influence what tool you're going to use as well. Because some of them have got dedicated tools and some of them are very general purpose tools. So the first one that I wanted to highlight is Test Kitchen. So this is grown out of the chef community for testing chef cookbooks, but it can also be used for testing other systems as well, like Puppet and Ansible and anything really. It's just a Ruby gem, so it's pretty straightforward to get set up once you've sort of dealt with the Ruby ecosystem. And yeah, so by default, it's really kitted out for executing for testing chef cookbooks. So if you're a chef shop, you'll probably be already using this or thinking about it. Yeah, it's a slightly path less trodden to test other systems with Kitchen, but it does work very well. So this is a provisioner for Test Kitchen that lets you execute Puppet, sort of Puppet classes. So spin up a VM, on VirtualBox or Docker or wherever, OpenStack, let's say, and then execute them with Kitchen. Sort of install the Puppet code, execute it, and then apply assertions based on top of it. And the same fellow, Neil Turner, has also written Kitchen Ansible, so you can test your Ansible code as well from Kitchen. Is anybody using either of these tools by any chance? Or Test Kitchen? No? Okay. So just going back a few slides, just sort of the minimum viable testing to add with Test Kitchen to a Puppet module looks like this. So this is the .kitchen.yaml file which you add to your project, and it just it sets up some stuff, tells it that the provisioner is Puppet. In fact, Puppet apply, because it does Puppet agent as well, so you can actually have a Puppet master and set it up like an actual agent talking to the master, or like this is a masterless Puppet testing. Yeah, so we're going to use Ubuntu 12.04, Vagrant plugin, and so on. And if we have time, I can demo this. Well, actually not quite this one, but a similar Puppet module being tested with Test Kitchen at the end of the talk. One of the things that's fairly common to do with Test Kitchen, or in fact any of the frameworks, is to use ServerSpec to actually write the tests or the assertions. So this is just basically looking to see if etc lsb release exists if it's an Ubuntu machine, or if Red Hat release exists on a Red Hat machine. So a pretty rudimentary test and probably not that useful, but just to give you an example of sort of minimum viable testing to your module. All right, next thing I'm going to talk about is Beaker. So Beaker is developed by Puppet for Puppet code testing. It's not really useful for anything else, although yeah, you can use it. You can use it to test other things. But yeah, you'll find that a lot of Puppet modules developed by Puppet and developed by the community use Beaker to do their acceptance testing. I would say the barrier to entry is a little higher with Beaker than with Test Kitchen in terms of sort of getting started with it. That said, though, if you are using Puppet and you want to have a look at how the tests are written by the developers of modules that you're probably using, you can go and look in your modules, and you'll probably find that there's a bunch of Beaker tests in there that are all ready to go, and you can execute them and poke at them and see how they're working. So ServerSpec is built on RSpec, and it's a way of specifying test conditions on machines. Like, make sure that after we built this machine that this package is installed, that it's listening on this port, that it responds to this HTTP request in such a way, and so on. And it uses the RSpec language and adds a bunch of its own syntax, not syntax, DSL, to make that work. So both Test Kitchen and Beaker can use, and usually do use, ServerSpec to actually, as the language to write the tests. So RSpec, which is what ServerSpec is built on. So that's the conventional test framework for Ruby. We also got RSpec Puppet, which is if you're wanting to do unit testing for your Puppet code, that is the sort of standard way to do that. A couple of other things are BATs. Has anybody used BATs by any chance? No. So yeah, Test Kitchen can use this as well as a way of executing the tests. In fact, one of the modules I can show you during questions has a BATs test in it. So that's actually a implementation of the test anything protocol. So it's very agnostic of what you're testing. You can test pretty much anything with BATs. The tests are written in Bash, so it's sort of very sort of low barrier to entry. Nice and simple as well, and not too many sort of hooks into other things. All right. What are some reasons to not write tests? It takes too long to write tests. So yes, it can take some time to get into the headspace and get your first test written and running. But after that, they're much easier and faster to get going with. And are you really saving money and time ultimately by not bothering writing testing of your infrastructure code? Maybe, but you're adding risk, right? If you're testing infrastructure code with acceptance testing, then you're really de-risking yourself and your organisation. So quantify the risks and work out what's the worst that could happen when you think about whether it's worth dedicating some time, carving out some time to get tests written for your infrastructure code. Who's going to run them anyway? Well, you can run them. Your team members can run them. New team members learning the ropes will benefit by reading and running the tests. So that's, or if you find yourself moving to a new team and there's tests there, you can go and examine those tests to get an understanding of actually what the intent of the code is, what it's supposed to be doing. And then executing those tests give you confidence that you've understood what the code's supposed to do, and gives you something to sort of see and poke at and get better familiarity with your code and what it's supposed to be doing. Mostly though, it'll be your CI system, hopefully, triggered by code pushes to Git, etc., that are executing those tests ultimately, so that you don't need to bother about running them manually unless you're hacking on them, or you're hacking on some of the things that they're testing and want to just verify it quickly before it goes through to CI and a pull request. So yeah, let's say a new team member does join your team. So it's not useful just for you, but for your whole team and for new people to quickly get up to speed with what your code is supposed to be doing. Maybe you can actually go on holiday now if your infrastructure has become that much more reliable, and you're able to develop a culture in your team where people feel safe to make commits and changes in the knowledge that their changes are going to be well tested before they go through to production. So you want to codify all of that stuff so that it's all automatic, and people don't need to worry so much about, did I do that thing? Is it going to all blow up? Wake up in the middle of the night realizing that things are probably about to go AWOL. Yeah, I mean, going back a good while now, I was working for somebody who said that I couldn't go on holiday because everything would just stop if I wasn't sitting next to the servers. So we're obviously trying to get away from that place. So could you reuse your monitoring checks for infrastructure CI testing? You may be able to reuse your existing monitoring checks so that you can have an easier on-ramp to integration testing. So rather than having to write tests from scratch and learn a testing framework and things like that, you can just spin up a machine, classify it like you would any other machine, and then point your monitoring to it, or just execute the monitoring check in isolation against that VM. So it can be a really good way to get to sort of quickly get started and then work from there on improvements. Another benefit with this is that you then have tests that accurately reflect the production monitoring. So you have better alignment with your testing and then actually what your monitoring is going to be in production. You can then test for and sort of ensure against things happening where your monitoring checks might cause trouble for your servers, for example. Maybe they're too intensive. So it gives you a way to sort of test your monitoring checks as well and a place to perhaps develop and modify your monitoring checks against your target machines. So yeah, what's your organisation doing during the questions? If you're doing something significantly different or even a bit different from what I've been talking about, maybe jump up on the mic and let us know what you're doing. I'm sure we'd all be pretty keen to hear what different organisations are doing in this regard. Yeah, so that's basically it for the talk. What I thought I would do is just set a demo going and of some of those tests, and while we're answering questions, because they'll sort of run for a few minutes. So yeah, if you've got questions, head over to the microphone and I'll just start this test. Right, so this is a sort of a fairly old module now that I don't think Gareth Rushgrove had modified it for some years, but it's a Puppet module to manage Mirage OS in order to build Unix microkernels, which is not something I know much about, so don't ask me about actually what it's doing. But I can execute the tests. And I will warn you that the tests do fail, so that's actually useful because you can see what a test failure looks like. So Gareth actually used Test Kitchen to write the tests for this, really as a bit of a test of that and see how that works. So because it's Ruby, I'm using bundler, so I'm going to go bundle exec. Actually, can you see that? Yes. So bundle exec kitchen help. We see the help. So it gives us the commands we can run. So I'm going to run test. You see that's going to do a destroy and then a create and then a converge and then a setup and then a verify and then a few other things. So it's sort of similar to Vagrant's command set, and that there's sort of supersets that run other commands in a chain. So let's just run that big test thing, and that's going to first of all it's going to destroy 2 VMs that I've already got running, and then it's going to recreate them. It's going to install Puppet, and it's going to copy the code onto them and execute, enforce that Puppet code and then apply some tests. So yeah, any questions?